Good morning, everyone. So today I will be presenting about our NLP investigation project, that is Teaching Assistant Chatbot. And this project is done by myself, Rohit, Akshay, and Dheeraj. So before I begin, I would like to go through the idea behind creating the project. So for any course, students usually have to mail professors regarding the class material, the schedule, when is the next deadline. Uh, Even though most of this information is available in the syllabus section on Blackboard, sometimes even the student wishes like it could be readily and easily available just by a click of a button, or just asking like Alexa, give me my next deadlines. So this project is actually an attempt to do just that. Before we started building our chatbot, we actually decided to explore if there are any educational chatbots available in the market and what all functions can that chatbots do. So we can find a lot. This is the only one that was available. It's called Juji. And it's actually a platform for professors to create their own chatbot. It's an easy to use plug and play kind of application where the teacher just drags and drops certain flow and creates the chatbot. So the main major features of this chatbots were answering student questions, sending instructor reminders, collecting student feedback, access to the learning materials. So we decided to make a similar chatbot. So our chatbot is actually for the NLP course that we are studying. So it can provide the study materials for this course, the deadlines for this course. Uh, it can provide the mini talk schedule. It can provide the course materials, also specific chapters if the student needs, and a lot more things. Now to build this chatbot, we used Rasa. So Rasa is actually an open source framework to automate text and voice interaction. And Rasa has a lot of important features, like it has state of the art NLU research. It can understand messages, classify intent, and capture contexts. It is modular, and you have to spend less time working around the limitations and more time building high value features while working with Rasa. So that's the reason we chose Rasa as our platform for building this chatbot. So these are the major intents that we developed. So first, the chatbot can provide you the class schedule. It can give assignment deadlines for any assignment or project submission. It can give a mini talk schedule for each user. It can provide class notes, reading material, and also the grading criteria for this course. Next, I'll explain the training pipeline for our chatbot. So Rasa actually follows, first let me explain what this pipeline means. So Rasa actually follows a set of steps to extract entities and to identify the intent from the text the user writes. So we have used the default pipeline that Rasa provides. So the first step that it does, it, it it's called white space tokenizer. So this actually creates a token for every white space separated by white space separated character sequence. The uh, next next element in our pipeline is regex featureizer. So what this basically does is, based on regular expression, it can extract different mm, matches corresponding to that expression. For example, like we had to classify a Minitalk intent if the user wants to know when his Minitalk schedule is. So there are many ways where a user can type Minitalk in. He could he or she could type Minitalk as a one word or two separate words or separated by a hyphen. So if we write a regex expression for this one expression to capture all these three uh, words, so Rasa would be able to better identify that intent. The next is lexical syntactic featureizer. So this actually it it uses a sliding window over each token and it identifies what the previous and the next token is, whether it's a beginning of sentence, whether it's an end of sentence, or whether it's a title. So this actually helps Rasa to identify entities from a user text. And next, it creates a bag of word representation of the user messages, which is basically a count vector featureizer. And the final step is a diet classifier. So I'll explain about this diet classifier in detail in the next slide. So what is a diet classifier? So diet stands for dual intent and entity transformer. So diet is a multitask transformer architecture that handles both intent classification and entity recognition. It provides the ability to plug and play various pre-trained embeddings like BERT, Chatbot, or Glove. So before the diet classifier, Rasa used to use a bag of word feature, as we seen in the previous slide. It used to output whatever output from the count vector featureizer was generated that used to be used to classify the intents and entities. But with diet actually uses a sequence model that takes word order into account, therefore offering better performance. So here in this example, suppose the user writes, I want to know the deadline for assignment 1. So the diet classifier will actually identify that the intent of this message is assignment deadlines and the entity that we want to extract is 1. So now I'll mention some of the challenges that we faced. So the very first challenge that we faced was extracting the proper entities. Although Rasa has a very sophisticated algorithm to detect these entities, we actually have to provide the right kind of data set, and we had to code it in a certain way so that Rasa could detect them. So that was a little challenging. Also, debugging the syntax error in the YML file or debugging the code in general was very time consuming. And also setting conditional roots for different responses. So that's all the conceptual or the theoretical part of a chatbot. Let's move on to our demo. I would like to show you how the chatbot works in action. So now I'll begin the demo for our chatbot. So to start conversation with the chatbot, you could just say hi. The chatbot will introduce herself. So we have named her Felicity, and then she will provide you all the tasks that she can do. So, but before she could do it asks for a name. So I'll just go ahead and type in my name. It will ask for your last name as well, and then it will store our name and for all the future conversation, it will refer to us by our first name. So to begin with, let me just ask the chatbot to provide me the books that are necessary for this course. So as you can see, it has provided a table with all the different books that this course suggests, as well as the link to go to download those books. Next, I can ask the chatbot to give me the schedule. So as you can see, it provides all the details, all the dates, and what are the topics covered during each of those weeks. You could even ask the chatbot if when there is no class. So it accurately did find out there was no class during week 2 and week 3. And the beauty of this is, even if you rephrase, I mean, you need not type the exact same thing to get the same output. Even if you type, it would give you the same. It will identify that the user is asking for this particular intent, and it will output accordingly. This is basically based on the training text that we provide in the NLU.wam. Next, let me show you how it could provide you the assignment deadlines. So here I mentioned deadline for assignment number 1, and it says assignment 1 due date is 10/3, 11 p.m. EST of that day. Similarly, I can just change it to, you can just write or for the deadlines for how the project works. I could write so it gave all the deadlines related to the project work, the proposal, the presentation, as well as the report. So next, let me just show you how a user could find out when his mini talk is scheduled. So if you remember, initially it asked the user for his or her name. So using that name, it would search the mini talk document, and it will output when the user has to present a mini talk. Let me just show you. So initially it will ask, when do you want the schedule as presenter, questioner, or both. Let me just type both first. Just ignore the error. It's just I mean, it's just an error that it just says warning message that I need to provide training set. But as you can see here, it outputs my mini talk schedule correctly. So I was a presenter on week 8 and questioner on week 7 and 10. If I just want the questioner details, I can even do this. So as you can see, it identified me as a questioner. And it could do that. And finally, let me just show you the last intent, that is of providing chapter notes. So it will first list out the different chapters, and it asks for the user to type in a particular name. Suppose I want to find chapter notes for deep learning. So I'll just type deep learning. And so it searches for deep learning in the chapter content and provide, so it found like so these are the chapter notes from our coursework which we have just uploaded on Google Drive. And if you just click on them, it will open up in your browser. Finally, you can also get the whole list of notes for a particular book. And you can download any one of them. That's all we had. Now we are open for any questions. Thank you.